wouldn't it be awesome if I could just move my hand up and the slide would go up? Or I would move my hand to the right and the slide would move to the right. I could even slide my hand to the left and the slide would go to the left. Or also down.
Yeah, that's the idea of MotionDream. Hello ladies and gentlemen, and welcome to our second technical presentation. With MotionDream, we want to develop a computer input device which is natural and easy to use. The system recognizes hand and finger movement of the user, and the main advantage of our system is the mobility of MotionDream, because we are not tied to any spatial boundaries. The project goals are to measure the diffraction of one finger, to establish a connection via Bluetooth to a PC, and to support a common operating system like Windows or Linux. Our optional goals are to control computers, play games, make music, and finally we want to combine MotionDream with the VR goggles or Oculus Rift. Our team members are Peter Poslasny. He is responsible for hardware, firmware and marketing, and me, Markus Reicher, I am the project leader and responsible for software and design. Together we want to make something modern and new, and therefore MotionDream is really exciting for us. Now we start with the technical implementation. As you can see in the block diagram, the most important parts are the flex sensors, the inertial sensor and the Bluetooth module, but it's easier to describe it with this. So, as you can see, if you move your fingers, the flex sensors generate a signal, and the signals go to the microprocessor. And also, if you rotate or move your hand, the inertial sensor communicates with the microprocessor. Then the microprocessor computes the input and then sends it to the Bluetooth module, and the Bluetooth module sends the data via Bluetooth to the PC.
On this slide you can see our wiring diagram, and on your left hand side you can see our charging controller. You can just use a standard mini USB cable to charge this device, and the controller charges the device fully on its own. And as soon as the device is full, an LED lights up. And there you can see the two connectors where you can connect the battery. Then in the middle you can see the connectors for the flex sensors. And on the right hand side are the connectors for the inertia sensor, which is connected by an E2C bus system. On this slide you can see the PCB that we designed and already manufactured. We tested this PCB and we used the practical knowledge that we've got through using this prototype to manufacture a second version of the layout, which we also manufactured, and I'm wearing it on my wrist right now, so it is working. On this slide you can see the housing, which we've designed using Pro Engineer, and we've printed it in the school using the 3D printer. So, since our device should be portable and still as small as possible, we decided to use lithium polymer batteries, which are small and still have a pretty high capacity. We have a battery usage of about 70 milliamperes per hour and a battery capacity of about 350 milliamperes per hour, so we get a battery runtime of about 5 hours. And we've also programmed the MotionDream control center, which displays every value, and this is useful during the development process. As you can see on the screenshots, there are the values for the movement of the finger and the rotation of the hand. The 3D cube moves as you move your hand, and the progress bars on the left side move if you move your finger. So on this screenshot, the thumb was bent to 100%. As you can see, there are two screenshots, And the screenshot on your left-hand side is a screenshot of the program running on Windows Vista, while the screenshot on your right-hand side is the program running on Ubuntu and Linux. And the presentation right now is running on Windows 8.1, so you can see it works on both platforms.
To describe our project state, we can say that our project or work is very well advanced, and we'll just have to optimize the software and write our diplomal thesis. Together we used about 240 hours of our working time, and we are glad to tell you that our whole project is sponsored by Jugend Innovativ with 340 euros, and our technical sponsors, Seventh Electronics and What for You. So we have about 130 euros left.
Our next steps are the testing phase, in which we'll optimize the software, and then the documentation, which we would like to finish as soon as possible. And if we have time left, we would like to program a Windows Runtime app. And we've already talked to Microsoft developers, and they said that they would support us if we would program such an app. And now we are glad that we are able to pronounce the MotionDream development kit. With this development kit, everyone will be able to program their own applications using MotionDream. You just have to download the API from motiondream.it, and you will be able to develop your own programs and games. So if you're interested, just make sure to visit motiondream.it for further information and documentation.
Finally, we want to thank our main supervisor, Diplom-Pädagoge Johannes Stelig, and our two secondary supervisors, Diplom-Ingenieur Gerhard Jüngling and Diplom-Ingenieur Franz Bräunig. We would also like to thank our sponsors for the support and you for your attention. Thank you.